In this video we're going to have a look at sequences and the notation that goes with them. So we can see here we've got the set of odd numbers starting at the number 1. And the way we actually go through and define them in terms of sequences is use the notation with T and a subscript. So we can see here the capital T that refers to the terms in the sequence, 1, 3, 5, etc. The subscript 1 in purple represents the first term in the sequence, which happens to be the number 1, which is in green. Now if we extend this notation to the next number, we can say that T2, which is saying the second term in the sequence, is the number 3. So the capital T refers to terms, the subscript refers to the position in the sequence, and then the number which it actually equals is the number in the sequence, which in this case could be 1, 3, 5, 7, etc. We can see a summary of that for all the numbers from 1 to 9 by using this table. So in this table we've got n represents the position in the sequence, which could be the first, second, third, fourth or fifth based on the numbers shown, and Tn refers to the actual numbers. So the first term in the sequence is the number 1, and then looking through the table, the fifth term in the sequence is the number 9. We can summarize all of this information from a table into a general rule that allows us to find any term in the sequence. So because the terms go up by 2, that means they match the multiplication table of 2. But when we check that, rather than go up in terms of 2, 4, 6, 8, they go up in odd numbers. So the general rule would be to multiply the number n by 2 and then subtract 1. And that allows us to find any term in the sequence. So for example, if we wanted to find the 15th term in the sequence, we could continue by adding 2 to each of the numbers from 9 onwards. But a quicker way would be to substitute into our rule. So to find the 15th term, in other words when n equals 15, we substitute it into the rule and we get 2 times 15 minus 1, and that gives us an answer of 29. So the 15th term in the sequence is 29. Another way to find terms in the sequence is to use what's called a recursive definition. Now if we go back to the original table and look at the numbers in red, we can see that they go up by 2 each time. So a very simple way to find the next number in the sequence, in other words the 6th number, is to say just add 2 to the number 9. What we could do in notation is to say that T6, in other words the 6th term, is equal to T5 plus 2. And then we could do that for the next term. T7 is equal to T6 plus 2. And the way that we can put this in notation is to put it as Tn is equal to T, and then the subscript would be n minus 1 to indicate the previous term, plus 2. So adding 2 to a previous term makes sense, but in this case we can see that we start at the number 1. We have to make sure that when we've got a recursive definition we give a starting number, because otherwise we might say add 2, but the question would be add 2 to what? So in this case the recursive definition is to say any term, that's Tn, is equal to the previous term, that's why it's got the subscript n minus 1, and then we add 2 to it to say it's going up by 2 each time. And in this case our starting number, T1, is equal to 1. Now we can express this same recursive definition another way, and this is often what you see on calculators. What we can do is say any term plus 2 gives the next term. So if we look at that again, Tn could be any term in the sequence, the third term, the fourth term, anywhere we like. If we add 2 to it, we get the next term, and the next term is referred to as T subscript n plus 1.